So say you wanted, launch Notepad. Say you wanted a counter that would count like from 3 to 30 by threes. And there's like 3 different ways you could write that. And I'm not putting this into idle. You could use a while loop. You could use a different kind of while loop that I'll show you. And you could use a for range loop. So the first while loop I'm going to show you uses modulus, to figure out whether, no it's not, I'm going to skip that. So the while loop, maybe I won't skip it in a minute, but it's not going to be the primary topic. The while loop, what you would do is you need a starting point. I'm just going to say start is equal to 3. You need a stopping point. And I hope none of these are keywords. If these are keywords, you know, you have to pick other words for them. And then you're going to need some kind of counter, which you would set equal to start. Now, if the loop is going to do anything else, maybe I'm not going to call that counter. Maybe I'm going to call that I for the iterator, or X for the iterator. An iterator is a variable that increases as your counting goes. It's called an, if you have a loop, every pass to the loop is 1 iteration. All right, so that's about enough, I think. But if you're going to be calculating sums or averages or stuff like that, you may need additional declarations, right? So I'm just going to put plus any additional declarations like total and count. Like if you were going to add, you know, like if you wanted to figure out the average, you would need the total and you would need the count. Alrighty. And we need a step. This is supposed to count every number from 3 to 30 by threes. So I'm going to make a step equal 3. So we're starting at 3. Let's make these numbers different. Like we're going to go from 9 to 30 by threes. That way, you know, we don't have any duplicate numbers. Right? So we're starting at 9. Our stopping point is 30. Each time we go up, we're going to add step to it. And we need some iterator. And then we may need a sum and a counter and stuff like that. But like I said, I'm going to leave that off for now. So the general form of a loop, and I'm probably going to delete these comments, maybe not, is initialize and then some kind of condition, while condition, and then some kind of body, and then an update. So you need to initialize your iterator plus, you know, whatever else. That's what we're doing here. These are initializations. Then we're going to have a while statement, and then we're going to have the body, whether it's printing something out or adding something, and then we need an update to our iterator. So initialize our iterator, do our while condition, do the body, and then update our iterator. That's the pseudocode pretty much for what I'm going to be doing. I'm going to push that, cut that up, and push it above my actual code here, which has got the start and stop, and the x is equal to 3, and the step is equal to 3. Okay. So we've initialized everything. So while our iterator, which I just called x, is less than or equal to our stopping point, do something, I don't care what, print x, and then add to our iterator. X equals x plus 3, or I like this syntax, and the book doesn't concentrate on it, but I love it, and I want you to see it. X plus equals 3, like that. Now that's not enough to solve the homework assignment. The homework assignment was like to do the average of all the numbers, you know, up to 100 that were evenly divisible by 4. But this is the structure. This is the body of the code right here. And if we were going to be adding something like a total, then you would just add x to it. So I'm going to go ahead and create a total variable and just set it equal to 0. But I'm going to put it below that comment. And then inside here, inside the body, total plus equals x. Add x to our total. Total equals total plus x. And then below it, you would calculate the average. Well, this isn't enough information to calculate the average. You need a counter. How many items have been counted? Right? So you're going to need something that just adds 1 to it every time that it iterates. You can't use the iterator as our counter because, like, if we're counting from 4 to 100, then the iterator is going to wind up being 100 at the end. And dividing by that would not give us the right answer. So we need some final variable here, some count, which we would start at 0. And then each time we do something, we're going to increment our counter by 1. All right, so that's pretty much the homework assignment, except you would need to, give different starting values here. It was going from 4 to 100, divisible by 4. And this will be in the notes. And down here, we would just calculate the sum and the average. Calculate the average and print it. So I hope that makes sense. I think that makes sense. Now, could you have gotten away without having so many different variables, constants up here, or not constants, but yeah. I hope that's not mine. All right, no problem. I was just paranoid. So, instead of x is equal to stop, we could have hard-coded that as 30, right? Don't do that. Instead of total plus, x plus equals, whoa, I made a mistake. I made the same mistake I was trying to avoid. What should this be? Not x plus equals 3. We want to increase it by the step. And sure, the step is equal to 3 at this point. We really want to increase it by the step each time. Why declare a constant if you're not going to use it? So then, if I wanted to do this the wrong way, I'd do that. And anyways, you see why I'm declaring these variables? So that if I wanted to change it to count from 4 to 100, it would be really easy, right? I wouldn't have to change this code at all. All I'd have to do is say, well, I want to start at 4. I want it to go up to 100, and I want it to count by 4s, right? So declaring your variables up top rather than putting what are known as magic numbers or numeric literals down here in the bottom, unnamed constants, there are several different terms for them, but magic number is a good term because if you're looking at the code, you might not know why we put 30 there, right? You might not know why we're adding 3 there. But if we see step, then we know, oh, I kind of know what it's doing, and I guess that's the stopping point and stuff like that. So magic numbers are numbers that appear in your source code anywhere other than in the declarations up at the top that aren't immediately obvious what they're doing. And you don't have to declare 1 as a constant, right? Count plus equals 1. It's just increasing it by 1. You don't need to declare a variable up here that would equal that. Okay, so that's one way of doing it. Here's a different way. I'm just going to copy this stuff, all of those declarations, so I don't have to type them in again. So if you're playing along, like I said, we're not typing this in idle unless you really wanted to, because I'm not going to double check it. So I'm copying all those declarations, everything above the while, and I'm going to do it with a for range. So there we go. So for x in range, go from the starting point to the stopping point plus 1, counting by steps. And then do our good stuff in here. Put in the body, which is to add, x to the total, x plus equals, total plus equals x, and then count plus equals 1, right? And then calculate the average, which is just total divided by count, and display it. Maybe you can see that doing it this way is easier than doing the while loop, right? Hopefully it looks cleaner. Yeah. This is doing it this way. We didn't even really need to declare this variable to begin with because we're redefining it there. I'd be just as happy deleting that line because I know that x is declared here as well. We don't need to declare it there. Okay, so this is the same thing as a while loop. It starts counting there. It keeps going until it stops. The +1 is because the range, like if you do a range from 10 to 20, that's going to actually count from 10 to 19. This is one past where you were supposed to be going. And I'm going to say that that's just a step of 1. If you were trying to count from 20 down to 10, well, you wouldn't put a 10 there because that would count only from 20 to 11. You would have to go one past it, but one past going the other way, right? So you'd actually want to do range 20, 9. So I'm just going to copy range. Yeah, let's get this all the way up here. Range 20, come on, 9, skipping by -1s, would count from, slow down, 20 to 10. Whereas this one, range 10, 21, counting up by 1s, would count from 10 to 20. So if 20 is supposed to be our stopping point, then we have to put 21 there. That's why I put stop +1 there. Ranges are really nice ways to set up what are known as definite loops. Definite loops are loops that just process through a series of defined values. Right. While loops are great if you're going to ask the user if they want to repeat or not, right? You don't know how many, pieces of data you're going to be processing or how many times they want to repeat. You're just going to process something, and then when it finally hits some certain condition, you're going to stop. That's great for while loops. But you can use a for range loop in order to count over a series of defined values or to iterate through a list. So what's a list look like? We've kind of done this before. I'm going to declare a list of our good old favorite phone number, 8675309 for the classic rock fans. And then for X in L, print X. That would print out one per line, the numbers, the digits, 8, and on the next line, 6, and on the next line, 7, right? Just like that. And if you were trying to add them all up or whatever, we could declare a sum. Sum is equal to 0, and then sum plus equals x. Honestly, if you're calculating the sum, you ought to just do this. Total is equal to the sum of L. We ought to use the built-in function to calculate the sum. But we could calculate the sum this way as well. You initialize it before the loop. You always initialize your stuff before the loop. And then in your body of your loop, you update whatever it is you're trying to add up. And then you don't need to update your iterator because that's all handled in the for. Just like in the for range, we didn't have to do x plus equals 1 or anything like that because the for statement took care of it. So fors are for defined definite loops. So who's done the homework that counts from 4 to 100 by fours? No? Only one? Well, the rest of y'all pretty much know the answer now. So just remember where it is in our notes, and you're good. But rewrite it yourself. Don't just copy it. You want to rewrite it yourself. All right. So while loops, you initialize. You put your condition here, you do your update. So this is supposed to be counting from 5. Is this going to stop at 1 or is it going to stop at 0? Is it going to print 5, 4, 3, 2, 1 or 5, 4, 3, 2, 1, 0? 0 is a good guess. It's not correct. Why? because this is supposed to be n greater than 0. So when n is no longer greater than 0, it doesn't repeat the loop anymore. And so 1 is greater than 0, it would print out 1, but 0 is not greater than 0, so it would not print out 0. So I want to mention breaks and continue again. Break causes it to jump to the first statement after the loop. And continue causes it to redo the loop right from that point on. And I know it's not nearly as interesting as when I'm making out type code. But anyways, so x is equal to 10 while x is less than or equal to 100. I'm going to print out x. I'm going to add 1 to x. And then I'm going to do some checking. If x is equal to 50, I'm going to break. Why don't I change this down to 10? And then if x is equal to 4, I'm going to continue. But I'm going to move that statement up. Oh, and I'm not supposed to be putting semicolons. This isn't Java. Okay, so I'm going to put that there. And as a matter of fact, I may put this statement up above it as well. So I really ought to retype it rather than going. But anyways, so again, initialize at the top. Do your body of your loop. Or initialize, comparison, body of loop, update. The update step is not necessary if it's a for loop. It happens automatically. So what does this continue and this break do? Well, x is equal to 1. Is x less than 10? It sure is. Is x equal to 4? Nope. Is x equal to 5? Nope. So it comes down here and it prints out a 1. Then it adds 1 to x and comes back up here. Is 2 less than 10? Sure enough. Does that mean it's equal to 4? Nope. Is it equal to 5? Nope. So it prints out x again. Adds 1 to it. Come back up here. Is 3 less than 10? Sure enough. So is 3 equal to 4? Nope. Is 3 equal to 5? Nope. So print it out. Add 1 to it, so it becomes 4. Jump back up to the top. Is x equal to 4? Well, now it is. So it immediately jumps back to the top of the loop. And as a matter of fact, it's an infinite loop now, right? Because x is still 4. It never exits the loop. That was bad programming. But I could fix that by doing an x plus equals 1 there, right? Just so that it didn't do an infinite loop. Anyways, so if x is equal to 4, it adds 1 to it, it's 5, and then it does a continue. So it jumps back to the top of the loop because that's what continue does, jump back to the top. And now it comes down here, is 5 equal to 4? Nope. Is 5 equal to 5? It sure is. Break, so it comes down here. It's done. So that's what this would print, is 1, 2, 3, done. Wouldn't print 4 because when it hits 4, it does a continue before it gets to the print. So it jumps back up to the top. Then it comes down here and it wouldn't print a 5 because if it hits a 5, it breaks, which means go to the first statement after the loop. So that's what continue and break do. Break. Force an exit from the loop. In other words, go to first statement after loop. Continue. Force loop to start from the top. Now that doesn't mean reinitialize and everything, right? It just jumps back up, to the first indented statement. Force loop to, start from the top, to go back to the top of the body, go back to the top of the body. So if you put a continue statement in a for loop, it doesn't reinitialize that counter that we have defined. It just keeps going like this. For x is equal to range, we're going to start at 1. We're going to go up to 10. So I have to put 11 there. And then if x is equal to 4, colon, do something to it, x plus equals 1. And who knows why you would want to do this. This is just for funsies. Okay, so when it said continue, when x finally equaled 4, it would jump back, well, it would add 1 to it, which would make it 5, and then continue causes it to go back here. first line of the body. It doesn't go back here and reset it down to 1. It just causes the body to reiterate once. And it's easy to make continue cause an infinite loop, like I did accidentally when I forgot to put that there. I take advantage of that when writing some loops. I do this while true, and then I get some input. X is equal to the integer of the input of, you know, type 1 for fun, 2 to quit. And if they type in a 1, we're going to print out yay, you know, fun. So if X is equal to 1, print fun. Wow, fun. Okay, but if X is equal to 2, then print, okay, done, and then break. Now, that is, in my mind, the easiest way to set up a sentinel value loop. But there are other ways. You could, you know, initialize the X variable to something up here, and then you could do while X not equals 2. If that's the way your brain works, that's totally cool. This avoids what is known as the priming read, because to do that accurately, we would ask them whether they want to run or quit right from the beginning. And then we would have to repeat that statement at the end of the loop. I guess I'll demonstrate that. I'm going to copy all this, and I'm going to modify it to be a priming read. For a priming read, you've got to get your input first. That's, you're priming the pump. You're getting the first input. And then after the body of the loop, you get your input again. Those two loops, whoopsie, whoopsie, whoopsie. This should say while X not equal to 2, because that's our terminating condition, right? That's our sentinel value. Okay, I don't know which one you like better. I like this one better. We wouldn't even have to put a break here if we have this while X is equal to 2. But I think we ought to. Or maybe not. Yeah, if we're going to do the priming loop, now it's actually starting to look a little bit better to me. You know. But we still have this code repeated, and I hate repeating code. If we had more than one choice here, if X equals 1, if X equals 3, if X equals 4, if X equals 5, then we wouldn't want to do it that way. So I'm going to change these to elifs. If X is equal to 1, do that. If X is equal, no, I guess I'm not going to. And then lastly, I would need to make sure that if X was not equal. Nope, I'm all good. Why am I confusing myself? And you're going, I don't know. All right, here's what's confusing me. If it's equal to 1, I print wow, fun. If it's equal to 2, which is our sentinel value, print okay, done. And then we do this again. So it's going to do that regardless of whether we printed wow, fun or okay, done. I don't want it to do this if they chose a 2. So what I would probably do is to have an if statement that prevented it from doing that. Like if X is not equal to our sentinel value. But that's looking lame. That's looking like a hack to me. I don't know why I wound up needing to do that. I'm sure we'll see another example in the code. I mean in the text of that. Alrighty. Onward and upward. Or downward since we're scrolling down. We've talked about break a couple of times. We've talked about continue. Definite loops using the for loop. Here's where they declare a list of friends. Friends is equal to Joe, Glenn, and Sally. And then for every friend in friends, print out Happy New Year, friend. Notice the use of the singular and the plural here. Plural is our list, right? Like colors is equal to red, blue, and green. And then the singular for colors in colors. The only reason I don't like doing it like that is because if I get up here and I write code and I use the same variable name, but sometimes there's an S at the end of it and sometimes not, I guarantee that some people are going to type the wrong thing. And as a matter of fact, I probably will as well. And so it just increases debugging time. But it's a perfectly good way of doing it. So this would print out Happy New Year, Joseph, Happy New Year, Glenn, Happy New Year, Sally. So this is a definite loop. It's going over a definite series right? It's not going over a range, it's going through a list, but same idea. This variable first equals that, this variable then equals that, and then this variable then equals that. So it'll repeat 3 iterations. Just like that. So to find the largest value in a list or sequence, what you do is you initialize a variable beforehand, and then if the value you're looking at is less than your current largest, then that value becomes your newest largest. And they're doing some special trickery with this none value. If I was going to write it, I would write a little bit differently. I might not initialize it to done, but my code would probably break if the list was empty. And there is such a thing as an empty list. Here's what an empty list looks like. I'm going to call this EL for empty list. Whoops. All right, that's an empty list. This gives us some problems for the kind of code that I was thinking about writing, because if I do this, largest is equal to the first value of the list. What's the index value of the first value in a list?
0.
Yeah, so, but if it's an empty list, we don't even have 0. That would generate an exception. If you have a non-empty list, then you're ready to rock and roll. You could step through it. So I'm going to write that maximum loop as though it's assuming it's a non-empty list. But I'm going to put a comment here. Oops, this would blow up. Because there is no value at 0 if the list is empty. Right? If you're on a street with no homes, then you can't find the first home on the street. So, assuming that the list is not empty, here is a that would find the largest value. So, are we going to read from a list of values, or are we going to ask the user for new values each time? I don't know. And why don't we go ahead and do this in idle, just because I want to keep you all awake rather than, playing, Farmville on Facebook. Let's, I know nobody does that anymore. So anyways, so assuming the list is not empty, this code would find the largest value. So let's make up a list. L is equal to, and just put some numbers in there, whatever you like. I don't care. Don't put my numbers in there. Just type some numbers. We're going to need a counter to indicate what's the largest value, but we just have to initialize it with some value. The code in the online text initializes it to the special value of none so that it can do some checking. But instead, we're going to just set the largest, the current largest, equal to the first value of the list. And then we're going to have a while loop that steps through that list. Excuse me, a for loop that steps through that list. For x in L, or for v, I like for v in L. Why do I like v? V for value. I like to use I as an iterator or x as an iterator if you're counting through a range, but I like using v if it's a value in a list. You don't have to do that at all. Okay, so if the value is greater than largest, right, the last largest that we knew about, then that becomes the newest largest. Largest equals that value. And then we could just print out the largest is, comma, largest. Something like that. Now, if we're going to be asking the user for input, it becomes more complicated, especially if we offer them the choice of exiting the loop, right, enter score, or -1 to quit, and they enter -1 to quit. You're back in that situation of having had no items in it, right? And so how could we have initialized largest to anything? And you might think that you could do something like this. Don't type this because I'm probably going to delete it, right? You can say, well, that's my largest value. And, you know, you're initializing it to something that's arbitrarily smallest, right? And then that's probably, you know, good enough to check to see, you know. But then at the end, you'd have to see if it equaled that special value. That's not doing much different than that largest equals none. All right, so what is that business about largest equals none? Like I said, none is a special value. I forget if it's capitalized or not. I have to come back here and look. Yep, it's capitalized. If you write a function like this, define, you know, silly, and it returns something, you can store that, you know, x is equal to silly. Since this is a function call, the fancy term for it is we are invoking the function. Now x is equal to 3 after that runs. But what if we have another one? Define dumb. And it doesn't do anything. It just returns. And you do y is equal to dumb. Well, what does y equal? Other languages wouldn't even let you do this, right? If it doesn't return a value, you wouldn't be able to store its value. But Python does. They've just decided that if it doesn't return a value, if it's not a fruitful function, then it returns the value none. So let's print out x and y at this point and just see what they are. I want to see if it prints out the word none. Just reminding myself, are we on k? Yep. So k.py. All right, so when I run it, x was in fact equal to 3 and y was equal to none. But you can set a variable yourself equal to none, right? So, you know, what they did is they did this. Largest is equal to none, and then inside their loop, I'm going to write a really simple loop for x in range 10. That counts from 0 to 9. The very first thing they do is to check to see if largest still equals none. So if largest equals none, then it's a problem, and we better set largest equal to whatever our current value is. And then you could do if x is greater than our current largest, then our largest becomes x. Then finally you get down here, and if largest is still equal to none, then you've got a problem. It didn't find any largest value. But we're going to check to make sure it's not equal to 1, in which case we could print the largest found was. Or why don't we just do that? Print the largest found was, you know, comma, largest. So if it didn't enter the loop at all, then largest would still equal none. Like if it was an empty list. Obviously this is not an empty list, but it conceivably could be. What do I mean by that? What if I told it to start at, I'm going to undo that, but what if I told it to start at 11 and then count to 10 by positive numbers? That's not going to be anything. It's not going to even enter the loop, right? Because it's going to set x equal to 11, and then it's going to check, is x less than 10? Well, 11 is not less than 10, so it's going to skip the entire loop, and it's going to get down here and print the largest found was largest. Yep. So that's why the author wrote it that way. I don't really care if you remember how to handle this special case of an empty list. I just assume that you remembered how to do it. Where'd my code go? Where'd my code go? Did I actually put it in the module here? Yeah, I did. Yeah, I did. All right, I'm going to copy that and paste that into the notes as well. Anybody need some typo assistance? Nope. That's no fun. I like getting up and wandering around. And you know what? If you're looking for the smallest, you do the exact same thing except you change your conditions. You do if variable is less than smallest, right? Not if variable is greater than largest. You do if variable is less than smallest. You just flip it, and then it works. All right, so an accumulator, a variable used in a loop to add up or accumulate a result. If we want to know how many times a variable existed when we did count plus equals 1, well, that's kind of an accumulator. If we're calculating the total, that's an accumulator. And then the counter, which I call the iterator variable. Sorry to go on a different thing than what they called it. But the counter is a variable that counts the number of times that something happened. Nope, that's actually what we did. Sorry. You initialize a counter to 0, and then you increment it each time you want to count something. So that's not the iterator variable. That's not the x and the for x equals, in range. Decrementing is reducing a variable. Initializing is giving a variable a starting value, but you'll update it later. Incrementing is adding one to it. An infinite loop is one where nothing was ever updated, so the terminating condition is never satisfied. In other words, the condition never becomes false. Now, an infinite loop, if you put a break statement or a return statement in there that can be triggered, then it's no longer a true infinite loop, right? Because if there's some way that they can break out of it, they type the signal value, whatever, then it won't repeat forever. My example would be where I did my while true loop. Right, this looks like an infinite loop because that condition never gets false. But eventually it hits that break statement, so it leaves it so it really didn't run forever. All right, that's about enough of chapter 5. So online text for chapter 4 and 5, well, this is timely. We have some homework that's due on the 26th over chapter 5, and it's due tomorrow, but we've already talked about most of this stuff. Let me go make sure that this is adequate, and I don't need to bump it up by a little bit of time. I'm probably going to set it to like Sunday or something. Give people a little bit of extra time. Write a program that reads numbers until the user enters done. Once the user types in done, print out the total, the count, the average, the minimum, and how many even numbers were entered. Well, that's worth talking about, how to check to see if a number is even or not. If the user enters anything other than a number, detect their mistake by using try and accept, and then print an error message. And here's how you check to see if a number is even. So to do the maximum and the minimum correctly, you should follow the example shown in the chapter 5 outline of using the none keyword. So you can do it like this. I say to do it like the chapter 5 online says. So go ahead and do so, even though I gave you examples contrary to that. So here's some pseudocode for it. The max value is none. Keep repeating while true. Input S. If S is equal to done, you got to break. Otherwise, you're going to convert S to a float. And then if max V is equal to none or max V is less than N, you're going to set max V equal to N. And if you're taking care of minimum, then it's just going to be if min is greater than N, then the min needs to drop. So you set min equal to N. All right. I don't want to write the solution for this for you. I hope we have covered enough. but I do want to do the evens for you. So let's go ahead and write something that asks for a number, and if it's even, then we will increment it, right? So I'm going to do a while true, and we're going to do an input about number is equal to input. Give me a number, or type none. Or how about type quit? Or done, whatever we're going to do. And then if they typed in quit, we want to break, right? Now quit is a string, so we need quotes around it. All right, but if number wasn't equal to quit, we need to turn it into like a float. I'm actually going to turn it into an int. I'm going to assume that they typed in a whole number, but we don't have any error handling in that case. So after we do this, we're going to add some error handling. So if, wait, we got to turn it into an int first. Num is equal to int parentheses num. And now we need to see if it's even. Here's how you check to see if something is even. You modulus it by 2, and if the result is 0, it was an even number. If num percent 2 is equal to 0, then we add on to our number of evens. Evens plus equals 1. Now, there's a problem here with what I just typed. That would generate a compilation error. It wouldn't run, or a runtime error. What have I done wrong? I'm adding 1 to the value of evens. Yeah, I never initialize evens. I better come up here and initialize evens. And if I'm calculating largest and smallest and average and stuff like that, I'd have more initializations to do up there as well. Alrighty. That's about enough for the while loop. But if we type in garbage, it's going to break. I'm going to go ahead and print done down here at the bottom, just so that I know it finished. So give me a number or type done. Alrighty. 1. Give me a number or type done. 3, 5, 2, 4. Okay, now there's some dumb stuff in here. What do I mean by that? I'm not printing out the number of evens found at the end. And then I'm going to type in quit, and it ran successfully. It didn't print out the number of evens, but if I print evens right now, I can see what it figured out. And yes, it found 2 evens, which is accurate because I only typed 2 evens in that series. But I ought to really print. Whoopsie, whoopsie, whoopsie. Right, I ought to go ahead and print my results here. Evens found equals, in quote, comma, evens, like that. All right. We could even write a special little message if we find out that it's even, right? But I don't really think that there's a reason to do that. Okay, but this code breaks if I enter something that's a non-integer. I didn't tell them to type in whole numbers, right? So if I type in 1.2, it blows up. I can use a try except block. What a try except block does is it attempts to do the code that's inside the try, and then if the code fails, it generates an error, just like what we saw, then it does the except block instead. So here's the dangerous stuff right here. This is the line of code that breaks if you type in a negative number. So I'm going to enclose that code in a try block. It means I'm going to have to tab these lines over right there. So just keep that in mind as I do this. I'm going above the num is equal to int num because that's the line that blows up if they type in garbage. Try that, whoops, it didn't tab it over. I need to tab that over because it's part of the while loop. Try that. That has to be tabbed. And so does this. and then except, in other words, if it generates what's known as an exception, if it creates an error, then we're going to print a message. Whole numbers only, please. All right, now we've added error handling. That goes like 30 to 35% of the way towards achieving the rest of the homework. So you just might tuck that away in your head. When you start in the homework, you can go and look in your notes of the code that you wrote today and upload if you're typing in notes. All right. So now I'm going to test it again, but I'm going to give it some garbage values after a while. 2, 4, 6, 2.0 or 1.0. Well, you would think that 1.0 is a whole number, but it's not because it's still got a decimal. So it says whole numbers only, please. It didn't count it. And then if I type quit, how many whole numbers did I actually enter? I entered 3, so it's going to print 3 evens found. And I'm sorry, when I said whole numbers, I meant even numbers. But in this case, they were the same because I never typed an odd number. About time. What if I made that singular? And I didn't remember that I'd made it odd, plural, up here. Again, that's why I kind of avoid doing plurals when I'm up here typing, but I didn't in this case. All right. And so give me a number or quit. All righty, I'm going to give you a number. All right, cool. I typed in a 2. Whole numbers only, please. Right. So it's telling me that 2 is an error. The deal is that 2 is not an error. The deal is that it's hitting that line. Evens was declared with an S. We don't have a variable called even without an S, and so it's blowing up on that line. But we didn't know, right? Well, we don't see that error because this try except is catching it, right? It's trying that, it's hitting that syntax error, and then the except block is handling that syntax error. So it's handling more than one type of error. It's handling both this one and that one. So if we did a little bit of restructuring of the code, we would be better off. What I should have done is had the except block up here before this part and only put the line that can cause an error, that I expect can cause an error, here. So I'm going to go ahead and do that. I'm sorry to be copying and pasting stuff, but I'm going to take these 2 lines of code and I'm going to cut them and paste them after the except block. But before I paste, I'm going to go here and I'm going to type break. No, I'm going to type continue because I want it to repeat the loop as soon as it finds an error. All right, now I'm going to paste that stuff that I copied, but it's indented too far. Why? Because I don't want it to do the even check only if there's an error. I want it to do the even check if there is no error. And I hope I got the indentation lined up right. What I should have done is format dedent. That would have handled it. So the reason this is a superior solution is because there's only one line of code in the try, right? And then when I run it and it gets to this point, it actually is going to crash. And you may think, but I don't want it to crash. Yeah, you do if there's a serious mistake like that. You want to be able to catch the error before you ship it to the customer. So I'm going to run the module. I'm going to type in a number, 3. Nope, that was okay. 2. And now it gives me the right error, that on line 54, even is not defined. So I would come over here. I would find line 54. Where's my line number counter? Hello? Icon has line numbers. Okay, forget it. I don't know why I can't get my line numbers to appear. But, right, it would tell me to go to that line number. I would see even, and I would eventually figure out, oh, I didn't declare that variable correctly. You know, I think that I've frozen my editor. All right. All right, like I said, this code is the basis for that homework assignment, but I am going to push the date of that homework assignment back a little bit. Let's go do that while I'm thinking about it. And chapter 4 is functions, which we have talked about enough that I feel comfortable leaving behind. Okay. All right. That's enough of that chapter. We don't have much time to go to the next one. Let's go take a look at it. Do read the online text yourself. Don't just accept that I'm covering it adequately. Always go back and read it yourself. Maybe I scrolled past something. Maybe I didn't give it justice, to your taste. So, chapter 6, strings. We've only talked a little bit about strings. Let's add like a few string statements to our code. A string is just like a list, except it's a list of letters, right? But you index the string the same way. If you say fruit 1, well, that's letter 0. And letter 1 is A. So when we printed out letter, then it would actually print out A. If we print out fruit 1, then it'll print out A. If you print out fruit 0, it's going to print out the B. If you print out fruit 4, well, you have to count them over. 0, 1, 2, 3, 4. It would print out an N. The index value for a string, just like for a list, has to be a whole number, right? It doesn't make sense to ask for letter 1.5 here, right? There's no letter 1.5. There's only letter, 1 and a letter 2. You have to make sure that you're not going past the end of the string, right? We have a string here that's of length 6. So that means we can access elements 0 through 5. If we access element 6, it's going to blow up. I'm going to scroll all the way up to the very top because I don't want to have to sit there and enter data, type in quit and stuff every time. So I'm going to make a string. I don't care what it is. How about hero is equal to Darth Vader? He's the real hero of the story. Here we go. So if I print out hero subscript 0, it's going to print out a D. If I print out hero subscript 3, what is it going to print out? R. T. R is a good guess, but that's 0, 1, 2, 3. Yep. So it's going to print out the T. Well, what if I do something a little bit funkier? Print hero starting at 0 and going up to but not including 3. Let's find out what that does. And then I'm just going to put an input statement, press enter to continue. Just so I don't have to do all the rest of this stuff. Ooh, what do you know? I botched this. I don't know if y'all botched it, but I sure did. I have to scroll back down to that except statement and correct it. That should have been a colon, and print should have been on the next line. I guess when I was trying to type in data, I accidentally overwrote code instead. Alrighty, so here, that was supposed to be a colon. There we go. Sorry about that, syntax error. All right, so, the first one, the 0th, the character at index 0 is a D. The character at index 3 is a T. And the character starting at 0 and going up to but not including index 3 is DAR. This is what's known as a slice. This is called slicing. I don't know who made up that term, but it's incredibly common. Maybe the inventor of Python did. This is a slice. and it will print DAR. So the slice starts at that position and goes up to but not including that value. So what if I do this? Print hero 1:2. What is that going to print? And it's not as obvious as you might think. Well, maybe it is. But anyways, where's index 1? Which letter is index 1? A. And what's, if we go up to but not including 2, well, where's that position? Well, that's 0 and that's 1. But that's 2, but it can't print out 2 because this is supposed to be up to but not including 2. So all that's going to do is print A. Now my shortcut for figuring out what it's going to print is to start at the, take the difference between these two. 3 minus 0 is 3. So starting at the first position and then going 3, right? 1, 2, 3. It would print out DAR. Now what's 2 minus 1? 2 minus 1 is 1, so starting at position 1 and printing a length of 1, it prints out A. Hopefully that makes it pretty easy. Because what if I do this? Print hero 4:7 without even trying to figure it out. Just looking at the difference between those numbers. How long is it going to be? It's going to be 3, right? So starting at position 4 and going 3. So 0, 1, 2, 3, 4. All right, so that's position 4 and then going 3. So it ought to print H space V. I'm going to put quotes around these things. Just because when you start putting spaces in, it looks a little bit weird. Now slicing works with lists as well as strings. Like I said, a string is essentially a list. So I'm going to declare another list and I'm going to put a couple things in it. I'm going to put numbers because they're easier to type than anything else. Like how about 50, 100, 150, 200, 250, 300. And now I'm going to print a slice of that list. Print L starting at position 2 and going up to but not including 5. Again, I know just by eyeballing these numbers and doing some subtraction how long this slice is going to be. How long is it? Yeah, it's going to be 3 long, and it's going to start at which number? Index 2 is which value? 150. Right, so it's going to print out 150, and then it's going to print out 200. All right, so that's slicing. And that's indexing into a list. What if you need the length of the list? You can get that. X is equal to len parentheses capital L. At that point, X will equal whatever the length of this list is. 1, 2, 3, 4, 5, 6. How about our hero? Y is equal to the length of that word, that hero string. Well, however long this is, I think it's 11. It's going to equal 11. Now, do you remember how in the range statement you can leave some parts off and it'll do some defaulting? Like back here. Well, here, let me just type it. Like if I did this for x in range 0, 10, 1, I can rewrite that just like this for x in range 10. Because if you leave off the first number, it defaults to being 0. If you leave off the last number, it defaults to being 1. Slicing works the same way. You can leave off parts of it. Well, there's only 2 things to leave off, right? You can leave off either the first or the last. So I'm going to print our hero string, and I'm going to leave off the first value, but I want to go out to 5. So what did I do? I typed in space :5 into brace. Now you don't have to put these extra spaces here. So this starts at 0. This is the same as 0:5. All right, now was it a big advantage leaving out that 0, did that save us a whole bunch of typing? Not really. So that's not so cool. But what if I wanted to print like from here all the way out to the end? What slice would I do there? Well, what is this starting position? It's 0, 1, 2, 3, 4, 5, 6. So I'd have to print a slice starting with 6, and what would I have to end at? Well, it's 5 characters long, and 5 plus 6 is 11. So I would have to put slice 6:11. That's way too much thinking. I'd just rather do this. Print hero 6 : and then leave the end of it off like that. Goes from 6 to end. Just like this one goes from start up to, but not including 5. All right, so lo and behold, 0 through 5 is Darth, and 6 to the end of the string is Vader. Now, are there other ways to do that? Yeah, you could calculate the length of it, and you could add 1 to the length of it, and you could put that there. So since we calculated the length of hero, you know, we can put y plus 1 there. Nah, that's so easy. Why don't I just do it that way? Well, what if I do this? What if I leave them both out? Like that. Well, that means start at 0 and go to the end of the list. So it's actually going to print the whole string. Like that. Print it out the whole string. Now, do you usually want to do that? Not really. But if you want to clone a list, that's how you would do it. Like if I want to make another list that's an exact copy of this list L, I'm going to call it L2. It's a copy of the list. I could do L2 is equal to L, leave off the first number, leave off the last number, and there. Now L2 contains a copy of the L list, a clone. Now what does that mean? What does clone mean? Clone is an exact duplicate, right? But it's some, like, right, if you clone me, then there's 2 of me now. And then if you pull the arm off of that other guy, I still have my arm, right? So now that we've got a clone of the original list, if we take L2 and we delete an item from it, L is still preserved. It's still its original data. We're just making changes to its clone. So if you make a slice like that, but the slice is the entire pizza, then you've cloned the pizza. That is about enough. I think that's about enough. There's a Dropbox K, so you can go ahead and upload the PY file to it. Are there any questions or any typos?